Hello, here we are again, still in the flipped mode. I hope that you're surviving it well, and our topic for tonight, well, actually it could be on the weekend, so you'll be watching this either the evening of the 11th or sometime on the 12th or 13th. We're looking at trig identities. I usually refer to them as trig IDs. We'll gather quite a few of them this year, I think up to around 40 some, but we get them in big batches, so they'll go kind of quickly. So what I mean by an identity is something that is identical. There's something that equals something else. So mathematicians love that when things are equal. So let's get on with the love here and see which ones I'm talking about. The first, and we're going to number them for reference, the first trig ID is sine of theta equals 1 over the cosecant of theta. And when I introduce sine, I introduce cosecant as the flip, or in the inverted form of sine, the reciprocal. So this represents that relationship. So I will put the similar idea. If these are reciprocals, what would cosecant equal in terms of sine? 1 over sine of theta. I think I heard that back through the magic mirror here that I have. So let's move over here and do the same thing with cosine and its partner reciprocal, which is 1 over, hopefully you're getting to know these, secant theta. And likewise, secant theta. So this is 1, I'm sorry, I said we'd number them and then I didn't number them very well. 1, 2, 3, now 4. Secant is 1 over cosine. And again, 1 and 2, 3 and 4 are just exemplifying reciprocals. All right. What's going to come next? I hear someone said it. We're going to start with tangent, which is the reciprocal of cotangent. And cotangent is the reciprocal of tangent. Oops. Forgot to stand on its head. It must stand on its head. There we go. So we have 1 through 6, the first 6 trig IDs. All right, the next one you won't be as familiar with, and I'm going to try to develop it. Your book just states it, but it kind of angers my mathematical soul just to give you something with no derivation or reason why, so I'm going to have to bleed it out of you. So let's say you have a right triangle, if you would sketch that, and sketch that, and we'll just call the sides A, B, and C. We've seen that plenty of times, especially in regards to the Pythagorean theorem. Let's go ahead and look at it from another one. So developing the 7th trig ID, I was wondering, and I'm sure you were wondering as well, what is sine theta divided by cosine theta? In order to actually come up with the answer, we're going to use this triangle to help us. Because we can rewrite the sine of theta, remembering sine is opposite over hypotenuse. So we have B for opposite and C for hypotenuse. So on the top we have B over C. And cosine, similar except it's adjacent over hypotenuse, is A over C. So how do I reduce or better combine those? So B over C, when you have a fraction divided by a fraction, it's the same as taking the top fraction and multiplying by the reciprocal of the bottom. And now we see the C's cancel and we get left B over A. But in this triangle, B over A is what trig function? Opposite over adjacent, and that is tangent. So The whole trig function boils down to this. Number 7, repeating number 7, but in a condensed form. Sine theta divided by cosine theta equals the tangent of theta. God's order. Kind of amazing. All the interrelationships we can find. And nothing does it better than mathematics. And trig here as well. Well, trig is math, but especially in trig. The 8th one, I'm going to take the 7th one and flip this on its head, which will cause me to flip this. So if I look at the reciprocal here, I have to look at the reciprocal here. So I get, instead of sine over cosine, I get cosine over sine. And that equals the 1 over tangent, but we already defined 1 over tangent up here somewhere. Let's see if I can go find it. Here we go. 1 over tangent. I'm sorry. Where'd it go? Where'd it go? Yeah, right there. I didn't see it. 1 over tangent here is cotangent. So coming back here, I can replace that with cotangent. So to put that one all together without the middle step, number 8, cosine over sine is cotangent. Alright. Let's go on to the next one, number 9. I'm going to redraw that triangle that was out of the screen, or it's out of the screen now. So the right triangle with A, B, and C. And I did mention the Pythagorean theorem. So I'm going to actually write that out in all its glory there for a minute. So I was wondering, and I'm sure you were as well, what is sine squared of theta plus cosine squared of theta? I'm going to have to divide this video into 2 parts. So the first part is going to end in a few seconds. So I'll go ahead and, oh, you didn't see that? Okay. Sine squared plus cosine squared is going to be developed now, not given to you. Sine squared in this triangle, here we'll use this as our theta, is opposite over hypotenuse. So we have B over C, and those are both squared because sine is squared. Cosine is adjacent over hypotenuse, so I can put in A squared over C squared. And I have this blank, this hole in my heart that I have to fill up. So with this, I see, sorry, like denominators. So I can put the B squared plus the A squared over the common C squared. But what does Pythagoras tell us that B squared plus A squared is? Right here. So I can replace this by substitution with C squared. Now I have C squared over C squared equals 1. So I can go back up here, and number 9 is sine squared plus cosine squared equals 1. So that's the 9th trig ID. So we're just finding a lot of relationships, things that are equal, and we're calling them trig IDs. And they will become very useful in the days ahead. So we're just putting in some building blocks right now. Let me shut this down and start again on part 2. Be right back.